Hi everyone, my name is Shojit Shah. Welcome to our YouTube channel Helm of Science. Today I am going to discuss about the very important topic of not only class 11 and not only class 12. This is a part of 11 and 12 and JEE and NEET also. Why I am saying this? Suppose if you are in class 11, they can ask you a question of acidity of phenols as a part of general organic chemistry, or if you are in class 12, then they can ask you a question as a part of the chapter alcohol, phenols and ether. So this part, the acidity of phenol, is very important in terms of 11 and 12 also, and the main part is that in JEE, NEET and advanced and in this competitive exam, one or two question is compulsory coming in every exam. Okay, these topics are very important. So today I am going to discuss briefly the acidic nature of phenol. So now first, what is a phenol? Suppose I am writing the two structure. Now the question is, in between then, which one is phenol and which one is not phenol? Suppose listen very carefully. We think that if any benzene ring is present with an alcohol, that is phenol, but it is not right idea. In this case, look at the difference in the two structure. In this structure, this OH group or OH group, the alcoholic group, is directly attached with this benzene ring. But in this case, the benzene OH have a benzene ring. That is correct. This alcohol have a benzene ring, but this OH group is not directly attached with the benzene ring. So this is when this is a very important point. That's when a OH group is directly attached with phenol or benzene. That is called a phenol. But in this case, this is not phenol. It is a benzylic alcohol. That is also a not alcohol. Benzylic alcohol. This is not phenol, but this is phenol, because here this OH group is directly attached with this benzene ring. So now my next question, this OH group, okay fine, I am removing this one and give it the explanation briefly. Now when we discuss the acidity of some organic species, mainly in case of organic species, we have to check the stability of the conjugate base. So now the conjugate base of this phenol is this one, or actually I can say this is acidic because it releases H plus ion. So this will be the conjugate base of this acid. Now my question is, what is the necessity of losing this hydrogen from this phenol? Because in this case, phenol is also resonance stabilized. Why? By how? Suppose this one, look at the resonance structure properly, carefully. Okay, then fine. This one minus charge come on this carbon, this will go in this position, that become OH plus, then this will participate and this will be the all resonating structure. Fine, there are 4 resonating structure. Fine. Now this is already a resonance stabilized structure. So what is the necessity of releasing this H plus ion and forming this phenoxide ion? This is called phenoxide ion. This is called phenoxide ion. This is called phenoxide ion. What is the necessity of formation of this? Now look at very carefully. When this species is going to in resonance, what are the structure? It look like that. Actually look like that. Okay, first one is this will participate, then their minus form, bond will form, minus charges form. Then in this carbon, minus charge will form. Then in this carbon, minus charge will form, and finally this minus charge will go and further phenoxide ion further phenoxide ion will form. Okay. Now in this both cases, both are resonance stabilized and the number of resonating structure are same. So how can I say that this what is the reason or what is the driving force of releasing this H plus? The reasoning of driving of this releasing this H plus is because in this phenol the oxygen have a positive charge. We know that oxygen is an electronegative atom and the positive charge of an electronegative atom is very much unstable. But in this case of peroxide ion, there is no positive charge come on this oxygen atom. Instead of that, there is a minus charge on this electronegative atom, and we know that the negative charge in the electronegative atom is so much stable. That is why the phenol is spawned to release a H plus ion and show their acidic property. This is the reason behind that phenol is a very acidic, not very acidic, acidic in nature. Fine. So my next question is that now I am going to comparing the acidity between phenols and acid. Read it very carefully. This is acetic acid, we know that, and this is phenol. Okay. Now my question is, which one have higher acidity? So again, it releases H plus and form this phenoxide ion, and phenoxide ion is going to resonance and form the stable resonating structure, 4 resonating structure as I have shown earlier. Okay. This carbon, this one double bond. Okay, these have 4 resonating structure, but when it release H plus ion, this will form this conjugate base or anion will form. The anion will take part in resonance and only show one resonating structure. Okay, here only show one resonating structure. Now, which one is more acidic? We can say from by the resonating structure, the number of resonating structure, that phenol is more acidic than acetic acid. Is this right? No, this is wrong. Phenol is not more acidic than any acetic acid, formic acid, benzoic acid, whatever acid. Phenol is not more than acidic than this aliphatic acid also. Why? What is the reasons? Because, listen very carefully at my point. In this case, although it has a 4 resonating structure, fine, but in this case, this resonating structure, this and this resonating structure, suppose this is 1 and this is 2, they are equivalent resonating structure. Look at very carefully. This and this are same. So when some species create equivalent resonating structure, that will get a higher stability than any other resonating structure. And second point, look at very carefully. Here, the 2 negative charge, in both cases, the negative charge coming onto this oxygen atom, that is electronegative. But in all cases except this one, in all cases the negative charge come onto this carbon atom. Now listen very carefully. Carbon is not electronegative atom, so the negative charge of any electropositive atom is not stable. Here the negative charge come onto the electronegative atom. That is why it is become more stable than this one. So in every case, most of the 99%, one exception is there, and I will show you. This group have present, then this is more acidic than any phenol. So I can say that acid is more acidic than any acid, aliphatic acid, aromatic acid, whatever it is, more acidic than phenol. This is the very important. Whenever you see this group and this group, forget about anything about the resonating structure. This is going to with a more acidic in nature. I think it is clear. Note it down properly. Now my question is on that, how do you chemically distinguish in laboratory between acids and phenols? Suppose in case of acid, any acid, we use saturated solution of bicarbonate, sodium bicarbonate, saturated solution of sodium bicarbonate. It will produce this one and release carbon dioxide and water. This effervescence of carbon dioxide prove that the sample or the species contain this carboxylic acid group, and if we pass with the lime water, that means the water consists of calcium oxide, then the lime water turns milky. Fine. This is the experimental proof of any carboxylic acid group. Now, if this reaction is treated, or this reaction will go through by the phenol, if we use saturated solution of sodium bicarbonate, no carbon dioxide will release, that means no reaction will occur. Okay, so in case of phenol, we cannot experimentally do the use of sodium bicarbonate. So this is the chemical distinguishing. Suppose in lab quiz or in theory also, they ask you how do you separate the any acid with any phenols. That is the experimental. But now the time of exception. I have said that there is an exception. The phenolic group has showing more acidic than benzoic acid. Now time of this exception. Okay, write it down. Now what is the exception? I am drawing this structure. This is the exceptional structure. This acid known as picric acid. It is yellow in color. Picric acid. This is known as picric acid. Now this acid is much more acidic than benzoic acid also. Benzoic acid, the structure of benzoic, what is the structure of benzoic acid? Benzene. This is benzoic acid. Fine. This has this COOH group. I just said that whenever you have COOH group, that is more acidic than any phenol group. But in this case, there is an exception that picric acid is more acidic than benzoic acid. Because you can observe this by a concept of general organic chemistry. If this release a H plus ion, then O minus will form. Fine. This O minus will form. Now this O minus or a negative charge, I have said very clearly in every video, if any negative charge is present, that is stabilized by the minus R, minus I and minus IH effect. These three groups have tremendously minus I effect and minus R effect. That's two minus I effect and minus R effect become or make this phenoxide ion too much stable that it become more acidic than benzoic acid. This is the exception. And if you give sodium bicarbonate in this phenol, the saturated solution of phenol, it will produce carbon dioxide and water also. This is the exception of our phenol that is more acidic than benzoic acid. In competitive exam, they can come question. They will set a question from the picric acid. So remember this one very carefully. So now I am going to compare the acidic nature of different species. So now this is our first example. So in case of when I compare the acidic nature of any species, first we have to remove the H plus. Now I am removing all H plus from the phenols. That is very easy for me, but difficult to all of you. Okay. Now these are the all phenoxide ion or conjugate base. Now very carefully, this is a negative charge species. Now negative charge species stabilized by minus I, minus R and minus H, and unstabilized by plus R, plus H and plus I. So fine. In this case chlorine show minus I effect and this will show minus I as well as minus R. Fine. There is no effect, there is no substituent present, so there is no effect. Fine. In this case there is a plus I, in this case there is a minus I but plus I. Okay. We know that OCH3 groups show different opposite in nature, that is minus I and plus I. So negative charge is stabilized by minus I and minus R. So this one become more stable because it has all minus I as well as minus R. So C1 is more stable, then B. Now these two are unstabilized because having plus I and plus R. Now this one is more unstable because it has a plus R. We know that plus R is more predominant than plus I. So and this one has no effect, so this one have no stability as well as instability. So next is A, third one is D, and last one is my E. This is the stability order of the phenols. Listen very carefully. I am going to show you 4 or 5 example, and that 4 or 5 example is enough for every exam. Okay, fine. Look at this carefully and write it down conceptually. So this is our next problem. Now my first job is formation of phenoxide ion, that means release of H plus. Again this is very helpful to me and difficult to all of you. Now fine, this is our phenoxide ion. Now what happened? This chlorine show minus I effect, and in both cases they both have minus chlorine, that means minus I effect. Now we know that the I effect, inductive effect, is distance dependent effect. That means with increasing distance the inductive effect, that may be plus I and maybe minus I, will decrease. Fine. So in this case the distance of this chlorine will increase from left to right, that means A to B to C. In this case chlorine present in ortho position, in this case chlorine is present in meta position, and in this case chlorine present is para position. Now, so in case of ortho position, the chlorine show maximum minus A effect because the distance is minimum, and in case of para phenol, that show in this case, so this is the chlorine is placed in the maximum distance. So in this maximum distance, the minus I effect is least or minimum. So it will show you the maximum acidic nature. That means this ortho substitute have most acidic, then meta substitute, then the para substitute. If this one is minus I effect, the reverse will opposite. If firstly write it down, I give you 5 seconds, pause the video and write it down. I think you can write it. So if there is present of CH3 instead of Ca, the order is reversed because CH3 has a plus I effect. CH3 has a plus I effect, and the plus I effects unstabilize the phenoxide ion. So in this case, it is present at ortho position, so it unstables axion phenoxide ion. So now in this case, the acidity order is reversed. That means C A B. Sorry, CBA. Sorry. First C, then B, then A. Fine. This is a 2 different question with 2 different group effect of substitution. Now I am going to the next example. Write it down. Okay, this is our next problem. Fine. Now in this case, you can see that in case of B, C, and D, both have a nitro group that means nitro group show minus I effect and minus R effect also. So in this case, this is least stable. There is no confusion about this. So this one is least stable. A. Fine. Now what happened? In this case, NO2 group present as ortho position. In this case, NO2 present as meta position, and in this case, NO2 present is para position. And we know that with increasing, and both have minus I. What happened? Both have minus R effect and minus R effect. Now what happened? In this case, between B and D, this will effort minus I effect more than D because it is present at ortho position and this is present at para position. So the order should be B, D, and in case of meta position there is no mesomeric effect, we know that. So there is only present minus I effect. So order would be B, D, C, and A. but this is wrong. But this is wrong. Why this is wrong? In both example, before we show you the both example, that minus I effect is distance dependent, that ortho position have higher effect, that may be plus I or maybe minus I, but in this case the reverse is order is reversed. Why? Let's look at very carefully. In case of phenol, who first release O minus ion. So in this case, look at very carefully. When acidity will show when is release H plus ion. Now in case of B, look at very carefully. I can write this one, and if I open up the nitro, that is look like this one. Now show very carefully. In case of orthonitrophenol, there is a chance of hydrogen bonding. There is a chance of hydrogen bonding, and this hydrogen bonding is too much stable. This hydrogen bonding is too much stable because of forming a 6-member stable transition state, or it becomes a 6-member stable hydrogen bonding or cage. Look at very carefully how it is 6-member. This is 1, fine. This is 2, this is 3, this is 4, this is 5, and this is 6. This is a 6-member stable hydrogen bonding. That is the why, because of the forming of hydrogen bonding with this OH and O minus of NO2 group, this H will not participate of releasing H plus ion. It don't want to release H plus ion because of forming of H plus ion. This is occur only in case of phenol. If there is a benzoic acid, there is a no 6-member will not form, hydrogen bonding will not form. On that case, in case of benzoic acid, that order will follow as previous. But in case of phenol, due to the formation of this 6-member stable hydrogen bonding, this will never release the H plus ion, and the acidity become less than D. So order should be, now what is the order? I think you can understand it. If you not, pause the video and show it again. D, then B. These two data will reverse due to formation of hydrogen bonding. D greater than B, greater than C, and greater than A. This is a very important problem of phenol that will come in every example. This can be a repeated problem of NEET and your board's exam also. So that is all for today. There is too much for we have discussed the acidic nature of phenol, why phenol will show you acidic in nature. Then I have shown you the difference, which one is more acidic than phenol or benzoic acid or acetic acid, whatever it is, but aliphatic or aromatic acid, that means carboxylic acid. Then I have shown you the exception, the picric acid. Then I have shown that which one, that means how do you chemically distinguish between phenol and carboxylic acid. And lastly, I was comparing the different structures of phenol, the effect of substituent on phenol. So this is enough for today. We have completed the acidic property of phenol. Next day I will make a video about some on the basis of some reaction mechanism, and most important in nowadays I have made the video that complete the chapters in 11 plus 12 as well as NEET and your community and any other competitive exam. So this series will go on. Okay, fine, that is enough for today. Thank you and keep practicing.